Okay, so we're going to go ahead and we're going to review our simple random sample, and then we're going to talk about two very special types of random sampling. And so with our simple random sample, we're going to go ahead and talk about how we can use our calculator to go ahead and help us pick a random sample for us. So suppose we wanted to estimate the amount of corn we could get from a cornfield, or the yield from a cornfield. The field is a square and divided into 16 equally sized plots, 4 rows by 4 columns. A river runs along the eastern edge of the field. So we've got a diagram down here. We've got a river right here. And then we've got our field over here. And it's divided up into 16 plots. And we want to take a sample of the 4 plots. So we're going to go ahead and we're going to get our graphing calculator, and we're going to go ahead and pick a random sample of 4 plots. So let me get to our graphing calculator, and the directions are right here. So the first thing we're going to do is we're going to make sure all of our graphing calculators are set to a different number, so everyone would normally get a different random sample. So then it's truly random. So what we're going to do is we're going to go to, we're going to type in our current phone number. So you can type in your phone number. I'm going to type in my school phone number, 861-5454. And then, let me go ahead and show this a little bit better. I'm going to hit the store button. So down here is my store button. I hit store, and then I'm going to go to math. We're going to go over to our probability menu, and you'll get familiar with the probability menu. And we're going to hit rand, which is random. So it's going to set our random number to that. We hit enter, and now that's my random number. So now what we're going to go ahead and do is we're going to pick a random integer. So here's our directions for that. We are going to hit math, go to probability. We're going to do a random integer from 1 to 16 and do that 4 times. So let's go ahead and look at our calculator. I'm going to zoom back in a little bit. So I'm going to go to math, go over to probability. We're going to go down to rand int for random integer. We want our numbers to start at 1, go to 16. And our first number is 9. So as we, and in fact, I'm going to go ahead and pick 4 more. So 9, 12, 10, and 15. So now we're going to go back to our thing, and we're going to mark off our picks. So 9, 12, 10, and 15. And so what's really nice about that is we got one from every single column. But the problem about that is that all of our plots are in the very bottom. So it may not be truly accurate of what's going on there because of that. So to try and accommodate for that, we've got another way of sampling. So I'm going to go ahead and talk about our next way of sampling. Okay, so because of those concerns, we've got those other ways of random sampling. And we do this because we may be concerned that we have this specific subpopulation that's being underrepresented. In particular, in our sample, we have this group right here that is totally unrepresented. And so we may have a lot more corn growing there than we do down below, or we may have a lot less corn and it's not truly accurate. So we're going to look at other ways to sample. They're a little bit more complicated, but when you're worried about a subpopulation being underrepresented, these are our options. Okay, so our first one is called the stratified random sample. The population is classified into groups of similar individuals. Those groups are called strata. Then you're going to take a simple random sample from each strata. And then you combine your random sample to become your full sample. So we're looking at a homogeneous group, and then we sample from each group. And then each little sample gets put together for our final sample. So we're going to go ahead and take a look at our river here. And our concern may be that if we pick everything close to the river, because the river is a good water source, we get a lot of stuff growing there. So what we may want to do is create strata of close to the river, not as close to the river, and farther away. So the farther away we are from our water source, probably the less amount of corn we're going to grow. And so this now makes sure that we get a little bit from each part, and we get a better idea of how much corn we're going to end up with. It's a better idea on how to figure out how much corn we might end up with. So we're going to go ahead and we're going to grab our calculator. And I'm going to do a random sample again. So I'm going to go ahead and I'm going to do that random integer, and I get the number 12. So I'm going to come back over here. I'm going to mark off 12. And now I have 1 from that column. So now I'm not going to pick any more from that column. So if another number from that column pops up, I'm not going to pick it. I want 1 from each column. So now I'm going to do another random integer, and I get 7. So I go back to my graph, and there's my 7. So now I've got 1 from that third column, no more from the third column. So now I'm going to go to pick another random number, and I have 9. And 9 is from the first column. So now I'm going to pick another random number, and it's 15. Well, 15 is from the third column, so I don't use it, and I move on. So I'm going to pick another number, and I get 1. Well, it's from the first column. I already have it. I need something from that second column, so I pick another number. 13. Nope. 2. Haha, there we go. Now I've got 1 from that second column. So now we've got something from each one, and hopefully it'll give us a better idea of how much corn we're going to end up having. So that was 2, 7, 9, and 13. Okay, so that's our stratified random sample. We break them up into groups that are similar. Closest to the river, not as close, so on and so forth. And then we take 1 from each sample, or maybe if we have a lot in that column, we might take 5 from each, just to get a good idea. Our last one is a cluster sample. And so our cluster sample will take our population and divide it into smaller groups called clusters. Now the idea with the clusters is you don't want the clusters to be very similar. Not like the stratas. The stratas like all males and all females, or all right next to the river and all far away from the river. Those are homogeneous, they're similar, and then you just take a little bit from each little group. This one is going to be groupings, but those groupings should be similar to your entire population. So you may take a look at, sometimes counties can be really similar in a state. And so then you can take a look at, well, instead of surveying the entire state, I'm just going to look at one of the counties that's similar to that. So then you randomly pick a county and you interview everyone or survey everyone in that county. And so this one's very different because you randomly select 1, 2, however many groups you need, but then you're surveying the whole group. So if you get to a point where you're trying to figure out, is it cluster, is it stratified, instead of looking at what type of groups you have, look at how you are sampling. Are you randomly picking a group and surveying the whole group? Or are you randomly picking from every single group? And those are the differences. Randomly picking from every single group is your stratified. Randomly picking a group and then interviewing the entire group, that's your cluster. And so now what we're going to look at is we're going to break this up into our groups. And before we went into columns because of the proximity to this river here. But now we want our groups to be a little bit more heterogeneous. We want it to have a little bit of everything. So now my groups are going to go across. And we accidentally ended up with something almost very similar to this in our simple random sample. But it was a simple random sample. We randomly picked it, so there was no purposeful bias. That was just due to chance. And that's going to happen sometimes with your simple random samples. Sometimes you get it really nice and varied and spread out. So now what we're going to do is we're going to pick one group. And then we're going to use the entire group. So I'm going to go back to my graphing calculator. I'm going to pick a random number, 8. And the one that has 8 in it, those are the ones I'm going to use. So on this one, I have 5, 6, 7, and 8 in my sample. So now what we're going to do is we're going to go ahead and take this situation and we're going to compare it with the actual results of what happened in this experiment or survey. So now that we've done this, I have just taken how much corn was found in each plot, and I wrote this 3 times. So here we're going to take a look at our simple random sample, and we're going to see how accurate that was to the true mean. So in my simple random sample, we were looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, and 15. So I'm going to look at those numbers, which is 6, 27, 148, and 97. I'm going to add those up and divide by 4 so I can average them out. And so I get an average of 69.5. Okay, now I'm going to look at our stratified sample. And so in our stratified sample, we ended up with number 2, number 7, number 9, and number 13. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. That doesn't seem right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me go back. Oh, that was 12, not 13. I wrote it down wrong. So this one. So we're going to go ahead and average those out now. So 29, 98, 6, 148. I divide by 4, 70.25. Now we're going to go to our last one. And that's where we took the whole row. That was our cluster. So 7 and 31 and 98 and 153. We divide by 4, 72.25. So now we want to actually compare that to our true average. So our true average was 70. Which one was the closest? Well, our stratified was the closest because it really took into consideration what was there, broke those down by the groups, and worked with us. It was our closest. But our simple random sample wasn't bad at all. It was only off by 0.5. Now our cluster one was nicer. It was easier to do, which is really nice when you're thinking about all the logistics of having to sample. And it's not that far off. So it's easier to do, but it's not quite as accurate. So just different things to think about. So here we have a possibility of some bad results. We do. We have a possibility that we could have never picked anything from these high yield ones, or we could never have picked anything from this one. We had a really good simple random sample, so our value was pretty accurate. Now this one is more complicated. There's more thought that has to come into this. But it had the most accurate results. So it's taking into consideration these little things, trying to make sure that everything's really accounted for in there, truly representative. This one, it's convenient. It's accurate enough. It's accurate enough, but not as accurate as you'd want to. So if it's a high stakes thing, cluster may not really be the best idea. But if you're just surveying and it's getting a good idea, it's going to be close enough. Medical stuff, probably not. Okay, so pros and cons of each random sampling method. Our simple random sample, it's simple to perform. There is a chance of over or under representation of a subgroup. There is that possibility. Stratified random sampling, a lot more complicated to perform, little to no chance of over or under representation. So it really counts for that. But again, a lot more work, a lot more thinking of trying to make sure. And then you have to be careful you're not biasing any of your results. And then cluster sampling, very convenient, but underlying patterns may cause over or under representation, and it may not truly be as accurate because of that convenience. But again, these are still good sampling methods that you can use. The main thing we want you to know is what is the difference between them. So we'll give you situations and ask you, which sampling method is it? Okay, and that is it for the 4.1b for class, and we will go ahead and see you next on the 4.1c.